Hello everybody, welcome to another lesson by me, Miss Pythagoras. In this lesson, I will teach you the rules of differentiation. This is lesson 2 of 5. Have you subscribed yet? You can also visit my website. The link is in the comments below. There you will find all the chapters in the syllabus. Let's start with the maths. Now, first of all, I want to explain the different notations. If it is given that f of x is equal to x squared, then the notation will be f dash x and the answer is equal to 2x. Can you see that little symbol? We read it as f dash x. If it is given capital letter D and an X and a square bracket with x squared inside, this is the thing that you have to differentiate, then D means differentiate and X means with respect to X. Therefore, the answer will be 2x. Then, a different notation could be d over dx, and this means differentiate and differentiate in terms of x, and then there's a round bracket and whatever you have to differentiate, and the answer is 2x. And then lastly, if it is given as y is equal to x squared, then the notation will be dy over dx is equal to 2x. And then this means you will differentiate y and you will differentiate in terms of x. Instead of finding the derivative using first principles, we use the rules. Now the first rule says that the derivative of a constant is always 0. Remember, a constant is just a number. There's no x. Remember that the derivative means the gradient on any point on the curve. So when I give you y is equal to 4, the derivative will be 0. And please note, can you see which notation I used? Since this was given as y is equal to 4, I used dy over dx. And then the answer, 0. But why? Remember, there's your y-axis, there's an x-axis. Y is equal to 4 is that line over there. That line is a horizontal line. And can you see that the graph of y is equal to 4 is parallel to the x-axis and its gradient everywhere is equal to 0. And that is why the derivative of a constant is equal to 0. The next rule says if f of x is equal to kx to the n, then the derivative is equal to n times k x to the power n minus 1. So what this means is you go to the exponent and then you take it to the front, it finds k and it multiplies with the k, and then you go back to the exponent and you subtract 1. There you can see you subtract 1. Now, determine the derivative if f of x is equal to 2x to the 4. Now, the notation that you're going to use is f dash x, that means the derivative, equals. So how you will go about doing this one is you will take the 4, the exponent, it goes to the front, it finds the 2 and it multiplies with the 2. And then you go back to the exponent and you subtract 1. Therefore, the derivative there is equal to 4 times 2 is 8, and on the exponent and the x, x to the 3. 4 minus 1 is 3. Another example, determine dy over dx if y is equal to minus 5x squared. So now, can you see it's given your equation as y is equal to. So therefore, the correct notation to use is dy over dx. Again, let's do it. We will take the exponent. It goes to the front. It finds minus 5 and it multiplies with the minus 5. You go back to the exponent and you subtract 1. Therefore, the derivative there is equal to 2 times minus 5 is negative 10, and on the exponent 2 minus 1 is 1. Therefore, the derivative is minus 10x. Third example here, determine dx, the derivative of 4x to the negative 3. Now you must be very careful. This thing says you must find the derivative in terms of x, and then it's given what you have to find the derivative of. So when you do it now, the dx falls away. And what I did here was I took the exponent, the minus 3, you take it to the front, it finds a 4 and it multiplies with the 4. You go back to the exponent and you subtract 1. Therefore, minus 3 times 4 is negative 12, x to the minus 4. And then you can also write this with a positive exponent. And that implies that you can take the x down to the denominator with a positive exponent. Therefore, it's exactly the same as minus 12 over x to the positive 4. Another rule for differentiation is if x is the denominator, first use the laws of exponents to bring to the numerator. So what that means is, if you have a look at this sketch here, if there's an x under the line, you cannot differentiate. What you have to do is you have to take the x to the numerator and write it as x to the negative 1. For example, I want you to find the derivative if f of x is equal to 3 over x to the 6. So the problem is that there's an x under the line. First, we bring the x to the numerator on top, and then we write it as x to the negative 6. And can you see the notation there? On the left-hand side, it's still f of x. It's only now when you're going to find the derivative that you will write it as f dash x. Then, to find the derivative, you will take the exponent, minus 6. It moves to the front. It finds 3 and it will multiply with the 3. So minus 6 times 3, and then you go back to the exponent and you subtract 1. Therefore, minus 6 times 3 is negative 18, x to the minus 7. And then you can either stop there or you can write your answer with positive exponents. And that means you will take the x to the negative 7 down to the denominator, and then your final answer, minus 18 over x to the positive 7. Another example could be dy over dx, in other words, find the derivative if y is equal to 1 over 4x squared. So your problem here is not the 4 that's under the line. That's fine. You cannot have an x under the line. Therefore, you first have to fix your sum. So you will take the x squared that's under the line to the numerator, and it becomes x to the negative 2 over 4. The 4 you can leave. Then dy over dx equals. You will take the negative 2. It will go to the front, minus 2x. and then you will subtract 1 on the exponent. So in the next step you can say 2 goes in itself once, 2 goes in there twice, and the answer, negative 2 over 4 x to the negative 3. I said minus 2 minus 1 is minus 3, and I think here I cancelled out. Therefore, the answer is equal to minus 1 over 2. And what I did was I said x to the negative 3 will go down to the denominator and it becomes x to the positive 3. Now the next rule is if there is a root, first write as a power. And remember, a square root is the same as x to the power of a half. And here on my little sketch you can see you cannot differentiate if there's a root. Determine the derivative if f of x is equal to root x. So first of all, I will write root x as x to the power of a half. And only now will I find the derivative. Therefore, f dash x equals. So what I did was I took the half, the exponent to the front, half, x, and then on the x I subtracted 1. X to the half minus 1 is x to the minus a half. And then if you want to write your answer with positive exponents, you can take the x to the half to the bottom, to the denominator, and it becomes x to the positive a half. And then anything to the half is the same as 1 over 2 root x. The next rule is if there are brackets, first simplify by multiplying them out. And if you look at the sketch here, you can see we've dealt with you cannot find the derivative if there's an x under the line. You cannot find the derivative if there's roots or surds. And now if there are brackets, you have to multiply them out. Determine the derivative, and then I give you bracket x minus 1 squared. So first of all, you have to write that bracket twice, x minus 1, and you can FOIL it out and it becomes x squared minus 2x plus 1. And only now can you find the derivative. And you deal with each term individually. So you will say, the exponent there on the first term, 2 goes to the front, there you can see it, x, and on x you subtract 1, 2 minus 1. For the second term, on the x, if there's no exponent, there's an invisible 1. So you will take the 1 to the front, it finds the negative 2 and it multiplies with it, and then you go back and you subtract 1 on the x's exponent, 1 minus 1. And then here where you find the constant term, a plus 1, can you remember rule 1 said that the derivative of a constant is 0. Therefore, there's a plus 0. And now on the first term, 2 to the x, 2 minus 1 is 1. So the answer there is just 2x. And then the second term on the exponent, 1 minus 1 is 0. And then x to the 0, anything to the 0 is 1. It finds the minus 2. Therefore, the derivative for this one will be 2x minus 2. Now on this example, I want you to find the derivative dy over dx if y is equal to x minus 3 over x squared. So when you go to the sketch down here, can you see whenever there's a square and its brackets, you have to first multiply out your brackets. So that bracket you can write twice and then you can FOIL it out. X times x is x squared. The second term will be negative 3 over x times x, and then x times minus 3 over x. That's your third term there. And then lastly, a minus times a minus is a plus. 3 times 3 is 9. And x times x is x squared. Then in the next step, y squared, you will just carry that one down. And here the x and the x will cancel and you're left with minus 3. On the third term, x and x will cancel. You're left with minus 3. And then on the last term, if you want to differentiate, remember, you cannot differentiate if there's an x under the line. So that x squared, you'll have to bring it up and it becomes x to the negative 2. And then I also said minus 3 is minus 6. And then here I said that here the x to the 2 under the line, you cannot differentiate. You take it up, it becomes plus 9x to the negative 2. Now you can differentiate. So the notation that you will use is dy over dx. Let's do it. You take the exponent, the 2, it goes to the front, it becomes 2x. You go back to the exponent and you subtract 1. The second term, the minus 6, the derivative of a constant is 0. And then the third term, you will take the negative 2, the exponent, it goes to the front, minus 2 times, it finds the 9, x, and then on the exponent, you go back and you subtract 1. Therefore, so the first term will become, if you look at the exponent, x to the 2 minus 1 is just 1, and you don't even have to write that invisible 1. So the answer there is just 2x. You don't have to write the plus 0. And then here, minus 2 times 9 is minus 18. And then on your exponent, negative 2, negative 1 is negative 3. And then if you want to, you can write your answer with a positive exponent, or we say write your answers with positive indices, or write your answer with a positive index. All of that means a positive exponent. Therefore, 2x minus 18 over x to the positive 3. The last tip that I want to give you is always check if you can't factorize first. So when I give you find the derivative with respect to t, and then I give you t squared minus 25 over t minus 5. Do you agree on the numerator, that means the top, you can see that that's the difference of two squares. And then you can factorize that and write it as t minus 5, t plus 5. Then in your next step, the t minus 5 and the t minus 5 can cancel. And then the only thing that's left for you to differentiate is t plus 5. Therefore, when you do the differentiation, you will say on the exponent there's an invisible 1. So you will take this 1, it will go to the front, you write it there, 1t, and then you go back to the exponent and you subtract 1. 1 minus 1. And then on the 5, the constant, remember the derivative of a constant is 0, and you can only write 0 for me. And then just to complete your sum, you will say on the exponent 1 minus 1 is 0, and then you end with 1 times t to the 0, and remember anything to the 0 is 1. So 1 times 1, and then the answer there is just 1. Now you know everything on rules of differentiation. In the next lesson, I will explain how to work out the equation of the tangent to the cubic function. Click on the video in the right-hand corner to take you straight to that lesson.